Okay, class. Today we're going to start vectors. Okay, so a vector is really just a way to show the direction something's going and how fast it's going. Okay, so it has length and direction. So this vector here would have a direction, and we'll talk about ways to say this might be 40 degrees north of east, and it could have a length, right? It's also known as the magnitude. The magnitude of a vector is just a length. So magnitude and length are the same thing, okay? And it will have a direction. So it could say the kayak went 20 degrees north of west at 3 miles per hour for 5 hours, right? So it has speed, it has length and magnitude all being the same, but it could have its speed, it could have length, but they just call it the magnitude. So if we still look at this vector CD, and you see how it's drawn with the little half arrow, the magnitude is all we're doing is we're going to find the distance. So in this case, it's just 2 squared plus 3 squared. CD squared equals. So that's 4 plus 9, 13. Let me radical it, so it's the square root of 13. That's the length of that. Now let's think of the direction. How do you think we're going to make the direction here? Yep, we're just going to use inverse trig. Let's call that theta. The tangent of theta is 3 over 2. So then I say theta is equal to the inverse tangent of 3 over 2. Let me pop that in my calculator. Second tangent, 3 divided by 2. Theta is 56.31 degrees. So we could say 56.31 degrees north of east. Right? And there's some other ways we will do directions that we're going to learn a little bit later on. Okay? So that's something for you to do. This is just showing you how to write it. It's in component form. So instead of using parentheses, we're going to use, like, it looks like the greater than and the less than sign. This is 2, 3. Same concept as if you were using coordinates for X and Y, right? But this is our notation. There's a student's complete for you to do. All right, now let's talk directions. We had the one way where we do it, where we describe what it is. It could be 30 degrees east of south. Another way we can do here, right? This is just a bearing. We will call this the bearing, where this is my 0 degrees, and we're always going to go counterclockwise. So that is 60 degrees, right? Because we're starting from 0 and we're moving 60 degrees counterclockwise. So if we look here, this is still my 0 degrees. This would be 90, 180, 270, and then the end would be 360, because that's a full circle, right? It's a full circle. So to find this, right, that's 180. If this is 50, that little part is 40, right? Because each quadrant is 90. So we have 180 plus 40. This will be 220 degrees. Again, each quadrant's 90. That's how we get this 40. Halfway around, 180. If you did a complete 180, you turned the direction around. Okay. Now, this next one, it may take you just a couple times to read it to get the flow of it, but it is written here, north 30 degrees east, okay? This way, the way we're doing this, it's different than the north of, west, etc. This will always be based off of north or south. It's always based off of north or south. So this one here, it says north 30 degrees east. So we start at north and we travel 30 degrees east. A bearing of north 30 degrees east. Yeah, I forgot. The other one's not a bearing. This one's the bearing. My apologies. So, north 30 degrees east. That's how it's written. So I'm going to give you another example. We might have. So that means we look at south and we hit 20 degrees west. That is how we look at it. It's always based off of north or south. So if I look at this one, we're based off of south. So it's south. We're going to hit 60 degrees west. I guess technically you could be north 120 east, but you want to keep it less than 90 because you can stay in that quadrant. Okay, so it's south, 60 degrees to the west. It tells you where your starting point is, and then it moves you either way. So here, guys, you have a couple students complete to work on, and then we will go over some more stuff in class. So this is just an intro of vectors, of what it is. Remember, magnitude, length, and speed are all the same thing. Distance formula, you could use trig as well. Law of sines, law of cosines. Direction, we have 3 different ways to do the direction. Right? We can just say 3 different ways. If we had, this is 40, we can call this 40 degrees south of east. We can call it south 50 to the east, right? Because this is actually 50. Or we can call it 320 degrees. Because at 320 degrees, we start here. We go all the way around. Remember our 90, 180, 270, that's 50. 270 plus 50 is my 320, or I can even think of it as 360 minus the 40 is my 320. So I have those 3 ways to do it.